All right, let's take a look at this AP Calculus question. I did this as a team test, so let's kind of go through it together. Good scenario of hot water dripping through a coffee maker, filling a large cup with coffee. Just a generic scenario. The amount of coffee in the cup. Okay, so the first thing I would do when I read that statement right there is I would probably circle the amount of coffee in the cup. And then I would discuss or think about what that means. So we don't have a rate, we have an amount. At 1 minute, there are 5.3 ounces in the cup. Just understanding those basics of calculus is important. And at a time from 0 to 6 is given by a differentiable function c. We have the definition for differentiable now. Differentiable means that you can find a derivative at every point. That means that its curve is smooth. There's no cuss, and it's definitely continuous. That's what differentiable means, where t is measured in minutes. Selected values are given in the table above. So classic calculus, we've got a table. Use the data in the table above to approximate c prime at 3.5. So we've got to use the data. What I noticed in class is that people wanted to put it in their calculator, set it up, try to find the function. But specifically, and that's not wrong, but specifically what we're looking for in a problem like this is that we want to approximate. So we want to approximate that function from at 3.5. And they're always going to do something like that, 3.5, and you're like, 3.5 isn't in the table. Well, but 3 and 4 is. So if we just do y minus y over x minus x, we'll get 1.6. Now what does that mean? Well, we found the derivative. We found the approximate derivative at 3.5. That means our units of measure should be ounces per minute. And that would have been worth 1 point actually for that number, and then 1 point for the ounces per minute label. And that is because they said indicate units of measure. That will be important. And part B says, is there a time t from 2 to 4 at which c of t equals 2? So from 2 to 4 we're talking about now. Where the derivative would be 2, or the slope would be 2. So let's take a look. I saw a lot of great work, like finding the slope from 2 to 3, 3 to 4. What is it from 2 to 4? If we go 12.8 minus 8.8 over 4 minus 2, we get 2. We get the exact value of 2. Now what does that mean? That means we averaged 2 over that period of time. Is there a point where it had to equal 2? And you can kind of use words here and say, in order for it to have an average of 2, it would have had to either equal it the whole time, or for sure cross it. And again, you can bring in your word differentiable, smooth curve. And then that would be plenty of words that said it had to cross it or equal it at least once. It could have been that the whole entire time. The work of, the slope here was 2.4, and the slope here was 1.6, is totally appropriate too. To have a slope of 2.4 and go to a slope of 1.6, we had to cross 2 because of the differentiable part. Great work. Part C says, use a midpoint sum with 3 subintervals of equal length indicated by the data in the table to approximate the area, 1/6 the area from 0 to 6 of the function. Using correct units, explain what that means in the context of the problem. So I would have expected by now that we would have graphed it. And once we've got our graph there, I think this problem really makes sense as far as the midpoint sum with 3 subintervals. Like, it will never be something where you have to search. If you graph this, I feel like it is appropriate for you to understand that 3 subintervals would be 1, 2, 3. Equal length. So the length of each one is 2. Once you look at it that way, I think it's pretty easy to see that that's the midpoint. That's the midpoint rectangle. And that's your midpoint rectangle. Once you have that down, once you kind of make sense of that in your head, really you're just calculating the area of a rectangle. So 2 times 5.3 plus 2 times 11.2 plus 2 times 13.8. And I think you get 60.6. And we've still got this 1/6 in front. So when we do 1/6 of that, we get 10.1. So what does that mean in the context of this problem? Because we just found the area of an amount. And that doesn't mean that much to us. But when we take 1/6 of it, and it was 6 long, we're finding the average. So what have we found? We have found the average amount of coffee in the cup at any time. I know that's not that easy to understand, but anytime we take that 1/6 of something like that, we should be finding an average. And I think that'll start making more sense when we get a little deeper into this math. As you're looking at D, at this point in our calculus career, I was kind of expecting us to, based on the work we've done in class, to actually put this in our calculator, take a look at the graph, and then really just press the button second, calculate. Number 6 is dy dx. And then you can type in 5. When you put in the number 5, it tells you dy dx at 5 is 0.866 ounces per minute. So I totally appreciate attempting the definition of the derivative on this problem. That's actually really cool. You should be celebrated if your team tried to do that. Don't be afraid in a problem like this to use the technology available. It's really not a very difficult derivative when we learn derivatives of exponential functions. But based on the work we had in class, I think you had to move to just second calculate, press a button, and get a number. Not a bad question. Let's take a look.